So what I'm going to do today is that I'm going to use a tool called processing. Processing is a development environment for creative computing. So, but the interesting thing is it also has a Python interpreter built in. So you can write Python code that is very visual. So on the screen now you can see here that I have source code up here with a setup and a draw function. And that is the main base of a processing application. So setup is called only once. And then draw is called multiple times continuously. So the first parameter size here just sets the window size, and then the second parameter is the background color of the window that is run. So to run this, I just press play, and you get a black window like this. So my idea is now to take the object-oriented exercise we did in an earlier assignment and try to do it more interactively and more visual, so you can see how it can work. So the first thing I'm going to do is I'm going to create a new module. I call it geometry. So in geometry, I will put my classes that we will going to use. So first thing here, just drawing things in processing very easy. There are several commands here. You can just do rect, for example, drawing a rectangle. I can put it on 50 by 50, and then I say it should be 200 by 200 wide, like this. If I run this, it will display a white rectangle like this. So my idea is now that we will implement the objects and classes that we did in the previous exercise, but using the processing tool here to actually display something on the screen. So the first thing I want to do is, in this case, I will create a base class for all the drawing, the shapes I want to create here. So I will create a class called shape. This uses a bit older Python version, so there are some things that you don't have to do in Python 3. In Python 2, you have to get all functionality object, you have to inherit from the object, which is a kind of generic Python object. So we need a constructor to initialize the object when we create it. So this will be like the point object in the other assignment here. So self, and then I will have coordinates here as input. I set them by default to a 0, 0, so you don't have to pass them if you don't want to. So I have some member attributes x and y that stores the coordinates. And to be able to represent this object on the screen, we need to have a drawing function, so it can draw itself. So I will create a draw self. And then I also want to be able to, the derived object should be able to, some of the functionality will be built into the shape object, but some other functionality will be in the derived objects. So this method will call doDraw method that will be implemented by the underlying derived objects for the actual drawing. In this case here, I just write an empty function here. So what you can do is you can put the pass declaration to create an empty function in Python. So the first object I want to implement is the rectangle object. So I call that class rectangle. That is derived from shape, so it has a position like shape. And then we also have the x and y coordinates as input by default, so we duplicate them here, and then we do width equals to, let's see, 100, height equals to 100. And then I have to call the constructor of the inherited object. So in this case, shape. You can't use the super function here because that's not available in Python 2. And then we pass along self and x and y. So this will call the init function of shape to make sure that we have x and y coordinates available. Then we add self.w equals to w. H. Then we have to implement our drawing function. So we implement doDraw. So in this case here, calling draw on the shape function here, we'll call doDraw. And this is, we delegate this functionality to rectangle here. So the shape in itself is an abstract object that we don't, we will not create shapes directly, but we will create derived objects of shape. So we call rect mode first. That is, we want to create the centered rectangle. So in processing, you can do that by setting the rect mode option. And then we do rect, and then we use our self.x, self.y, self.w, and self.h, like this. Now we have our first two objects that we can use to draw. So let's save that and go back here, and then we create a rectangle here. Rect equals to rectangle. And we put it on, let's see, 100, 100, and then we 200, 200. And then we have to draw this rectangle. So rectangle, draw. That will call the, first it will call the draw method of the shape object, and then shape will call doDraw, which is re-implemented here in our rectangle. So it will call this method here. So hopefully we will have a rectangle on this. I have to do an import as well. From geometry, start that. A rectangle here, and it's placed on 0, 0. And if I want to change the position of a rectangle, I can do that as well. So rectangle x equals to now the position has changed. So we want also the shapes to be able to have different colors. So in processing, you can set different colors by calling certain. There are functions called fill color, fill stroke, and those things you can call. And we want all objects to be able to have colors. So if you have something that you want to be functionality want to be available in all kinds of objects, you should put them in the abstract objects, for this case, shape. We need to have a line color, the self.stroke color, that is the color that you used for the pen to stroke. And it's a color that this is a special data type built into processing, where you specify 3 color values, so red, green, and blue. So in this case, we put red, and we need to have a fill color as well. We do that yellow. So that is the first value here is the red color, and it goes from 0 to 255. Second is green, and then blue, and then it's a mixture. So if you have red and green, we get yellow. So So let's implement this here. So in our draw method here, we do stroke, self.stroke, and then we do fill, self.fill. Should do it correct here. I should do it like this. This is the way you should have variables in Python. So if we run this now, we will get a yellow rectangle here with a red line around it. So now that these colors will be available for all the derived objects that we create. We also want to have be able to control the line width, so we put self.line width color, and we'll make that green. No, not so green. We can make it green like that. Now we set stroke weight, which is a function in processing for setting the line width. Self.line. So running it again, you can see here that it is a bit thicker line around it here. You can see we can do. It's not getting very much bigger. Okay, it's getting a bit bigger at least. So now we want to create another object, another class here, and this time we will create a circle, or I think the correct term in Python is ellipse, but we will create a circle object. So class circle, derived from shape, constructor. We have x equals to 0, y equals to 0, and then we have to specify a radius here as well. Radius equals to. We call our derived constructor, so in this case shape dot init. Then we call x.
Jonas?
Yeah.
Just question about, when you define class and then you write like circle, or so why do you put shape in parentheses and not object or self, or
Yeah.
when you do a class, exactly, so there you put object, but when you define rectangle you put shape.
Yeah, because I want the rectangle to be like a shape. So it should derive all the functionality from the shape. And the shape is the base class on top, which defines the behavior of all the underlying classes. And the object name there, that is an old Python 2 thingy that you have to do to get the functionality that you have in Python 3. So you don't have to specify that when you do your code. So if you don't derive from anything, you create a new class that doesn't inherit from anything, you just do class shape. But you can see the object is the main class of Python is called object. So every class in Python always inherits from this special object type.
Okay.
But in Python 3 you don't have to specify that, it's automatic. But in Python 2 you have to specify it. And here I say for rectangle here it inherits all the functionality from shape.
So from class shape.
Yeah, from class shape, all these things I specified here will also be part of shape of the rectangle class.
Okay, and what? Okay.
So it's something so things that you, if classes share behavior, that should be in the base class. So for example, in this case, stroke color, fill color, and line width, all of those will be available for the rectangle as well as for the circle.
Okay.
So I will show you when we implement this here. So now
excuse me.
Yeah.
May I ask, or
Yes,
someone
okay.
else?
Yes, go ahead.
Yeah, I'm just wondering, for example, when we have like this inherited classes, if we want to have like a loop, for example, in one of the tasks we had, we needed to create like some points from a point class, but we didn't already know, for example, how many points we want to have, how many times we want to call this point class. So what I was thinking was to have kind of a loop depending on, for example, an input value that we say, for example, this time we want 5 points, or next time we want 3 points. But then in this self, for example, self, when we have 2 underlines, and then we want to say, for example, self P0, self P1, I wanted to have like an array. So that I say, for example, for I in range of the, of the desired number of points, get these this parameter, this self point. But then it complained that you cannot have such kind of variable in class name. For example, you cannot.
But I would come, actually this thing will come in my example here. So, but the main thing is that you will not. So the clause definition is to define the behavior of a single object. How a single object is created. The actual creation of the objects you do outside the clauses. You create objects. You can have a loop that creates multiple objects and adds them to a list, for example. But the clause only describes one single object. But in the class you can have, of course, a class can consist of multiple objects as well. Then you can have you have a list inside your class that contains other objects. I will show that as well in this. I will go through all the kinds of things that you actually asked about shortly. So
yeah, thank you.
Please just be patient, and I will come.
Can I just ask a quick question also? In the base clause here, you first define do draw. Yeah. And then self, and then pass, and then you define draw, and I don't really follow why you. This is what the role of the two are.
The role is because you could just have one single draw, then you have to kind of repeat call the previous draw from the other class, just like you did with your shape method for shape init, for example. So I've decided to have there are some functions that you need to call for all objects. So I put them in the generic draw function, and then the actual drawing of geometry I delegate to the do draw. So when you call draw on any object, it will first set the colors and the line width, and then it will call the method of the class called do draw. And for shape, it's kind of pointless because it's empty. But for rectangle, we re-implement the do draw. So it will first call draw, set the common parameters, and then delegate the drawing to the derived class.
Okay, so the base class is called every time you call rectangle. So the draw command will be carried out automatically in some way.
Yeah. So draw is part of the shape class, and in rectangle inherits that function. Rectangle also has the draw function, but it will kind of, because I haven't re-implemented here, it will build the shape draw that will be called. And when it comes to this position, if it's a rectangle object, it will call this one here. But it will first do these functions here in the code before it calls the underlying do draw.
But that draw command there is in some way being run automatically because it's not clear where
this is called polymorphism. So when you create a new object, for example, Python knows which draw to call. So if you had, for example, draw implemented in rectangle as well, it will first call, and the object is in rectangle, we first try to find the function in rectangle. And in this case, we don't have a draw here. So it goes up in the hierarchy and finds the draw function and calls that one. And then it goes down here, and then it calls this draw function here. And because the object is a rectangle, it will search the rectangle first for a do draw and call that one. So if we remove this, if this one here is not used, it will be called this one here. So it will kind of, depending on the object type, call the correct methods.
Yep. Okay.
So if you look at rectangle here, if we, for example, if we run
then we call draw here, and then it's sort of passed on there. I see. Yeah.
So this will be, so this is a rectangle object. It will look at the shape.
Yeah.
First. I'll first look at rectangle. There is no draw. It goes to shape. Oh, there is a draw, and then use that one.
Yeah. No, I follow.
Yeah, and also if you have a draw function here and you re-implement it here, that will be the one that the latest one will be the one that is called.
Mm-hmm.
So this one overrides this one here.
Yeah. Right.
Now I only have to do do draw here as well for the circle. I do ellipse mode here instead, so kind of then we do ellipse. I have some pre-baked code here, so I don't have to type too much. Like that. And then we can create another object here called ellipse or circle. Now I have to call it here as well. So circle. Let's specify radius here. So stuff wrong. So now I have a circle here as well. But you notice here that I didn't have to do anything about the colors here. So the colors we defined in the shape function, the shape clause, and we derived it from the shape. So both of them have the possibility to change the colors will be used from the shape implementation. But you can change them as well. So if we do circle, what's it now? Fill color. It's blue. So, but the ability to change the colors is built into the shape object. The final class I want to create is the one that a lot of you have been struggling with, is the Polyline Clause. So the idea with this one is that it should handle a set of points and draw between these set of points. So let's see here. Now you can choose if you want to derive this from shape, but we want to have the line colors and stuff like that. So we want that out for the polyline as well. We call create an init. Now by default we don't have any points in this, so this should be an empty polyline clause. And then we do shape. Now we have to have a container to store our coordinates now. So now we do self dot shapes. Oh, sorry, no, shape points. We do an empty list. And in this implementation here, I've decided that we store pairs of X and Y coordinates in the list so we don't have a specific point clause here. We store the coordinates directly in the list. We need a method for adding point. So let's go Y. And then we do self.points transfer. And I also have the method for clear. I have to also implement the way of drawing this. So in this case, we don't want it to be filled, so we do no fill. Then we do begin shape, which is a way of drawing lines here. So we do 4p in self points. Then we do vertex. And then we do add our coordinate. This is also something it's a sign choice. If you want to have the shape, the polyline as a shape that can be moved using X and Y coordinates, or it should have absolute coordinates here. That is the design decision that you can make. Nothing is design choice. Plus self.y. Then we do end shape. Now we create a polyline here. And then we have to draw here. So polyline. Let's see if I can get it right for the first time here. No. Add point. Okay. Okay, it was drawn behind. It's inside. I have to move it. Now I see I set the X and Y coordinates for that's coming from the shape, and that will be added to the polyline points when we draw it. So, and now I see I have a polyline down here. So, one thing that we should kind of optimize here is that we need some kind of object that could handle multiple objects. It should be able to consist of other geometry shapes. So what we can do then is create a class composite shape.
Excuse me.
Yeah.
In this class, do draw self. How did you define how many times I mean, how many points we have created? How many times we have called?
So how the loop should be, how it knows how many points there are, or so in this case, I created so every time I call add point.
Mm-hmm.
I add those x coordinates to this list here. So
now, for now, there are 3.
yes.
Okay.
And then you can, in Python, you don't have to use a index to in a loop. You can use the range loops if you want, but you can also iterate directly over the points like this. So for P, this is a point, one in this list here. So P will contain the coordinate pair. So P0, that is the one of these here, and this one here is this one here. So X and Y coordinates. So this will know when the list is it will know how many good times it has to kind of loop over that automatically.
Yeah. And this begin shape and end shape are the syntaxes for...
That is for this processing environment. So these are functions that are used to draw. So it's I will give you the link to where you can get this program and use it. But this is just for, I think it's easy to illustrate when you can actually interactively see things. So that's why I'm using this. So for the composite shape, I also initialize here. Then I have a self.shapes here. That will store other shapes. It's also a list, and then we have to possibility to add shapes. So add self, shape, and then we have to implement the drawing function here as well. So draw. And now we need to kind of actually call our draw functions in our own shapes. So in this case, we do for s in self.shapes. And then we call the draw function on each of these ones. So we go back here again, and then we do. Now, instead of having all these separate shapes here, we can add them to create our composite. And then we can add them together. So we do composite, add rectangle. So, now instead of calling them each one, we can just do composite. So no difference than before, but now we have a kind of object that can contain other objects. And the interesting thing here now is I can actually if I set the position here, so composite let's see here. I will not implement it, but you could set the position of the entire composite to make it move all the objects inside. But now just see it as a container of other objects. So the final thing I want to do is to just see how we can make it create objects that can move on the screen. So we could add to all of our shapes here some additional attributes. Self dot dx for speed in x direction. D dot y. Start with that. And then we need a method for updating the position of the object. So we add another method here, self. Then we do this is a very simple particle here now. So self.ex. Like that. And now we also have to, for the composite objects, we need to do the same thing, but instead of, so def So what I'm going to do now is I'm going to create random objects instead of creating fixed objects here. So I'm going to we may have the composite still here, but then I will, let's see, for I in range 20. Then I will create circle objects here. C equals to circle random. Like this, and then we do composite C. And then I will also set Vx equals to random, let's see. So random function can either take a single argument, then the random number is from 0 to the value, or starting an endpoint. Let's skip that one. Now we can do composite draw and composite update. Let's see if it works. Yeah. So what we did now, we gave all our shapes the possibility to move. So I can do a rectangle here as well. So because I put the update facility in the shape, every derived class will be able to move. What we can then do is, for example, if you want to create a simulation box for this simulation that makes the objects bounce, we could derive a class from Composite Shape. Now I will copy it over here. So what I do now here, I define a box here that is certain size, start left and right position, top and bottom position, where the particles should bounce in some ways. And then I add a method here to def check bounce. Also need to have a shapes equals to property. What I do now here is that I loop through my shapes and check for the bounds. If they hit the bound, and if they hit, I just reverse the speed. So don't take this as a super particle simulator. It will not be the best one, but I hope it will illustrate my ideas of object orientation. So now we create, instead of composite shape, we create a simulation container, and I 0.0, and then I say it should go from 0 to 1,000, 0 to 1,000. I don't have to change this code. I only have to add so it calls draw, it updates and check bounds. So now I derived all the functionality from the composite shape in the new class, not added the functionality of checking the bounds. So let's see here if it's. Perhaps I should make them a bit smaller. They are bouncing here. The center point of the boxes are bouncing. And I can also do, for example, C dot fill color equals to color. And you can see that all of these objects are independent from each other now. Each of them has their own value of the color, own line width, and so on. So they're actual memory allocated for each of these objects in memory. So I hope it was better. I could give you a better understanding of object orientation with this kind of concrete example here that illustrates the basic concept. So every time you see, when you do coding and you do classes, every time you duplicate code, that is a candidate for going into base class. So if multiple classes have the same thing you do all the time, that is something that should go into the base class. And also if you and also another important object is the composite shape here. Inheritance is one way of doing things, but it's also that you can create classes that consist of multiple objects, and that is also one important in object orientation, that you can create classes that are consistent of other classes. For example, if you take a car, it has wheels, and you can have a car class that has a set of wheel objects connected to it. There is no relationship between a car and a wheel. You can't inherit anything. But for example, you can have a car and you can have a truck. And you can have an inherited relationship between a truck and a car, but not with a truck and a wheel or something. So composite objects are classes that contain other objects. And in this case, I have this composite class here that contain other classes as well. And I have a question here about the rect method in Spider. So unfortunately, it's not this drawing functions are not available in Anaconda. And there is a library you can download called processing.py. I will give you some links to that, but it's not exactly the same like with processing, but similar. Any questions on this?
Yes, I have a question. If in this geometry, if you go a little up, where you wanted, because no, not too much. But for example, when you have this rectangle shape, then it means that it's an inherited class, right?
Yes.
But you do not have this super when you want to.
Now this is because processing only supports Python 2.7. The super function, as I showed in my course, is not available here.
Okay.
So you could have written like this in Python 3. Super. So this is the way it should look in Python 3.
Yeah, okay. But the line above now is how we make it understand that it's an inherited class.
This one is inherited. Then you need to call the init method of the inherited class. Otherwise, it doesn't get the attributes of the inherited class.
Okay. Yeah. And one more thing is that the arguments should be given an initial value.
That is optional.
Okay.
If you don't give a value there, you have to specify all the parameters when you instantiate the class. So if you give it like this, the user of the class doesn't have to give X, Y, and W and H. The default values will be used instead. So it's just a way of making it easier to use the class.
Okay.
Yeah. Okay. I wanted to show also some of the development environments that you can use. I should have done it earlier, but I think it's a good way of showing them anyway. So my preferred development environment for Python is I use either Spider or Code. The Code is the Microsoft's editor that is available for download on any platform. And it has a lot of extensions for Python. So I will show that now. Let's see if I can find it here. So this is the Visual Studio Code editor. And it has, there is a tab here called extensions. So when you install it by default, it doesn't know anything about Python. You have to tell it to actually use Python. And there are several extension packs that you can use. So there is one called Anaconda extension pack that will add functionality related to the Anaconda Python environment. There is Jupyter Notebook support built in. Pylons for language, so it kind of can analyze your Python code. IntelliSense, which gives you the way of when you put dot, it will show you the methods. So these are things I have installed here. And if you have installed here, it will, if I open a Python file, it will recognize that this is a Python file. And you can choose down here, it's kind of difficult to see here, you can choose which Python environment you want to use. In this case here, I am using Conda here, so you can see 385, but I can also change to another Python interpreter here. So every time you install a Python interpreter in your system, it will be installed so you can list them, this developer can find them. So in this case, I have this one, just check that one, and you can press play here to actually run the application. Now it was, okay, I have two different ones. So if we go through here, the upper tab here, that is all the files that you have open, or also shows if you open, you can open a directory, then it will show all the files in the directory. So usually when I use it, I have to have my command prompt here. So if you have a command line prompt in either Windows or Linux or Mac, you can type in any directory, you can type code, and I usually do code dot. It will open code in that directory. And that is the preferred way of doing it. If you're working on Anaconda, it's also a good idea to start with a command prompt and type code dot to start it. Then it will pick up that they are using Anaconda and do the right thing. So if I open a Python file here, you see here it automatically recognizes and colors the code in using the syntax highlighting from Python. And I can press play here to start the code. So now, as I'm from structural mechanics, you probably can see that this is a continuous beam. So this is a Qt application running. What you can do also in code is that you can, for example, set breakpoints. So if you want to debug the code, you can put a breakpoint here to say, I want to stop here. And then I go to, there is a run and debug thing here, and then I press run and debug the currently active Python file. Now it starts the program, and hopefully it should hit this breakpoint at some point. So now you see here, there's a yellow arrow here, and there is a breakpoint. So the code has stopped here. And here you can see the local variables in your instance here. And you can browse around and see where your code is. And then you can control your code running here by using step over. Then it will go to the next line, like this. And there is also step into. That means that it will go into the function on that line, this yellow arrow points. So we'll try that. Now you see it went into new model, and now I can continue to step over. And if I want to continue running it, just press this continue here, and it should bring up the program somewhere. Oh, it's behind. Oh. So that's a good, useful thing to have. And then you can stop the code here using stop and the stop debug. So this is the editor, and then you have this debug function here as well. So that was Visual Studio Code. I can also show you here, if you do, for example, self dot, it will recognize all the objects here automatically. So B model dot, and it will find the attributes that are from that object automatically. Most of it is also available in what's called Spider. You've probably seen Spider here already. And now why I did get this 4 version here. Okay. The Spider is a development environment a little bit more on the side of MATLAB, so it's more customized to be run interactively. You can create matrices, all that stuff. So let's see if I can go back to that. So in the top left here, you have Variable Explorer. It will show the variables in your code. You also have the files here. So in this case, I have the same application I showed before here. And one thing I would like to note with Spider, when you're running Qt applications, because Spider itself is a Qt application, it could be useful to make a setting here to make sure that your code doesn't interfere here. So there is a run configuration per file here. And then make sure that you execute in external system terminal. But otherwise, if you have a Qt application running in a Qt application, you can have problems. So usually the recommended way is to make sure that this setting is set. So if I run here, you get same results here, but with a bit larger scaling. And then you can stop here as well. Yes. You can debug here as well. So if you click outside here, you can set a breakpoint, I think. there. Then you press, so the first play button here, that is the run file. That will not debug anything. If you want to debug, you need to press this button here, debug file. So let's see, run that one. Okay, now I know why it does this. Okay, we'll try. Could be that you can't debug using this external terminal. This was a bit surprising. Okay, now it's apparently works. I don't know why, but so now it stopped here, and now you can, just like Visual Studio Code, you can step over, run your code. You can let's see here, we can have something. Trace into, and it goes into this function here as well, and you can run continue here. Ah. Now I really messed it up here. Let's see. Yeah, I will try to make a video on that. So, but it's possible to run debugging here as well. And then the basic idea is that you set breakpoints, and then you run the code, and you can step through the code. So that was basically what I wanted to show today.